Hello everybody, the iLord Root here, and welcome back to another Unity tutorial. Today we are going to be covering the game of Hangman. Now most of us probably are familiar with this game simply because we had played it as children. And before I get into the rules I do want to point out that I have done some boilerplate work. This is just to make the episodes progress a little bit more quickly. However, at this time, I'm still leaving code available. I've created a bit of the user interface for us. And you can see I've created this Hangman object from an empty object. And I've got a sphere and several capsules here. So the idea is that these are going to be the parts of the Hangman. Now, to some degree, I might do this as a model. But really we don't need to, because if you recall, in Hangman, you have several body parts, and you're trying to guess the letters in a word. And in this particular case, when we get a letter wrong, what will happen to us is that we will essentially put one limb onto the scaffold, and then when the entire body is hanging, then we lose that round. Now, of course, it doesn't make a huge amount of sense if you really think about it. For instance, if you're able to mount a decapitated head, the chances are that the victim or prisoner or whatever that's being executed is already dead. Likewise, assuming that you could somehow keep the head alive long enough, then all it would really take to hang the prisoner is the torso. But hey, it's a game. I mean, we don't really need to worry too much about this sort of thing. And so what I'm going to do now is I'm simply going to begin looking at our game controller object. Now, we have two classes here that I've already written. I've put them in a namespace of their own. So we have the Hangman Controller for the Hangman. And let's just get some public fields there while we're at it. We're going to have a game object named head, one named torso, one named arms, and one named legs. I believe that is the order in which these guys are set up. And we actually do want to do some initialization here. I'm going to have a private int tries, and I'm going to have me a private game object array called parts. Parts, as you remember, is pretty easy to set up. We just set these guys in order. And I'm actually going to create these guys in reverse order. So we'll say new game object. How about we open a brace there. We'll put in the legs, then the arms, then the torso, then the head. Now, because we're moving through this array backwards, what we need to do now is we need to populate this guy. So we'll say that tries is equal to parts.length minus 1. So that'll start at the last index of this parts array. Now you might ask, okay, we know there's 4 objects in there, right? But maybe instead of hanging a person, perhaps you might have like an arthropod. And without getting too much into arthropod biology, they grow from segments in their larval form, and you've got lots more areas you can, remove. So for instance, you can imagine maybe a game in which you're hanging a cockroach, because nobody likes cockroaches and they deserve to be hung. And so you might get something close to, I don't know, maybe 7 or 8 tries out of it, to where this guy at most would have 6. There are other things you can do as well. You could lower a dude into a boiling vat, or other things. Creativity is the key here. Anyway, let's go to our game controller. We need some fields here as well. So I'm going to create a public text. And actually, we need to briefly import a namespace as well. We're going to call this, or rather, we're going to import Unity Engine UI so we can get the text. And we'll say public text score indicator, which will track our score. Public text, how about word indicator? And then public text, I don't know, we have a indicator for the number of letters, so we'll use letters indicator here as well. So there we go. We're also going to have a word which we will store as a string, so I'm going to have private string word. I'm going to create a character array each time the word is set, and so what we will do here is we will have a private char array, and we'll call this revealed. And then finally, we will simply go through and we will say private int score. And maybe as well a Boolean value for whether or not the game's been completed. Now here we are going to create a number of functions. So I'm going to create a public function called next and a public function called reset. Reset will get called during the start, and reset is responsible for doing a number of things, which includes creating the hangman itself, or not the hangman, but setting the score. So we'll say score is equal to 0, completed is equal to false, and then next. Now in next, we're going to need our hangman reference, and incidentally I have attached the hangman to a tag, the player tag, so we'll just call this the hangman, and even better, Hangman Controller. Here we need to, of course, initialize this, so we'll say hangman is equal to GameObject dot find GameObject with tag player, and then we'll get that hangman component, or that hangman controller component rather. So that'll work for us for now. Next, we'll be responsible for setting the word. And so what we'll want to do there is we will want a private method that'll say set word indicator, or update word indicator, and we will pass in the word in question. Now for now, we're just going to use a deal like this. So we'll use one word. We'll use full maybe. Nice 4-letter word. And what we can do with that now is we can simply set the word indicator. So this is going to be a string called word. We're going to set this word equal to the word, and then we're going to create a new character array, and we're going to say revealed is equal to new character array word dot length. So this matches up exactly with the word here. other things, of course, is we have another deal where we have the letters indicator, and we'll set its text to the length of the word. And then finally, we want to actually update the word indicator itself. So we'll say word.text is, or word indicator rather, dot text is going to be equal to something like the following. In fact, we want to do something before we do this. At the beginning here, we actually, and we need to do actually set word here. Now we'll update the word indicator. Just like that. So, we have this buffer that shows us what has been revealed. And when we create this guy, we will actually do this thing to where we have the, we have a blank string. So the easiest way for us to do that is to iterate over this array. We'll call this string displayed, and we'll just use the empty string here. And we're going to use a for loop. We're going to use a different for loop than we've seen before. The other for loops that we've used before are something called for each loops, in which you have a collection, and you're iterating over every single element in this. But in this case, we have a range. So what we're going to do is we're going to say, well, I is less than revealed.length, and increment on each turn. So this guy right here sets initial conditions. This guy sets the condition for the loop to progress. And it will even do that if the no iteration has been made. For instance, if this is length 0, which should not be possible here, but let's assume that it is, then what will happen is that this guy in particular will be, this guy here will have 0. I will not be less than 0 in that case because it's initialized to 0, and so 0 is not less than 0, and no pass of the loop will be made. With arrays, this is perfect because that basically means that you'll never run past the end of the array. So we will have a number of things here. The first, in fact, being, we'll make this a void here, it doesn't need to be a bool. I'm getting a little bit ahead of myself. But here, we're going to build up the display string. And all we'll say is character C is equal to revealed.I. Initially, these guys will have a value of 0, not the digit 0, but the numeric value 0. And in Unicode and ASCII, that's the null character. Now, the deal with this is that it's kind of hard to think of characters this way, but characters are treated sort of like numbers in most programming languages. And so you can do arithmetic on them, because the characters are often ordered in a way that would give a sensible collation order. The collation is just sort of like the order in which it's sorted. So like when you try to sort alphabetically, that would, you have basically the numbers arranged, the characters arranged in such a way that these guys are in order. that we can use less than and greater than on them, and we can actually do arithmetic on characters as well. If you want an idea of what that might be like, I'm going to post a link to an ASCII chart that you might find useful. It doesn't cover all of the characters in Unicode, but ASCII covers virtually everything within the first code page. There are a few minor differences, but you won't have to worry about that. And so, anyway, what we can say is if C is equal to 0, then we'll just use a blank there instead. A blank being an underscore. And then we'll say display or displayed plus equals a space. And this can be useful because Arial is not a fixed width font, so you don't want this thing to shrink. You also want the user to be able to see exactly how many letters are in there, even though they've got that letters indicator. And then we will say displayed plus equals C. Now we can see if that works. What I'm going to do first of all, however, is I'm going to go through and assign some things here. So just wait for this guy to update. Update word indicator. Oh, it's set word. There we go. So yeah, I mean it's entirely possible that we might have bugs here, but I don't believe we will. At any rate, we'll just drag these body parts on here and worry about them later. I will show you how to make them disappear. And we have to go to our game controller as well and drag on our text fields. But when we do this, you can see now that we have 4 words. However, this is not updating. So we need to figure out why. If we go here, it looks like we forgot to do the one critical part. And that is, of course, word indicator dot text is equal to displayed. And if we set this up correctly, then what will happen is that when we run this, we will get a whole bunch of blank spaces. The reason for that, incidentally, is simply because of the fact that we have those values initialized to the null character, and so that is going to translate to a blank. And we don't need to do that every time because we're creating a new array object whenever we supply a new word. Now that's fine and dandy, but how are we going to select the text? Well, there's a couple of things we can do here. I'm going to create a new folder. I'm going to call it util. And what I'm going to do is I'm going to go into util and add a new class. And you can do this just by right-clicking in the editor. I'm going to call this guy text utils. That's a C# file. And that is going to be in a namespace called util. Formatting, of course, I need to change this so that it actually uses my preferred deal. But this will be the introduction of something called a static class. Static classes only contain static methods. And so there's no way for us to go on through and, create an instance of this. It's strictly not necessary, in fact. But yeah, what we'll do here is we'll create a public Boolean public Boolean, we'll call this is alpha, and we'll pass in a character. Now this is where that collation comes into play here, because in fact I'll name this as U alpha for is uppercase alpha. Basically, an alphabetical character has to be greater than or equal to A and less than or equal to Z. That's surprisingly easy to do here. All we have to do is say return C is less than or equal to. We're going to use the single quotes here because those are what character literals are formed from. So we'll say is less than or equal to A, and C is greater than or equal to, what was it, Z, capital Z. And that's a public static bool. Likewise, we want here to see if we've got a lowercase alpha. We want to use lowercase a and z. Now that is fine and dandy, and you can see as it compiles this thing, it should do just fine. And we'll use this to see if we've detected, a key that the character or the player can press. However, the fact of the matter is that we have something else to think about as well. What if we don't care about case? Well then, we need is alpha. And now we have to worry about operator precedence. So, in terms of Boolean algebra, which is the algebra of truth and falsehood, so to speak, it's one of them, anyhow. There are two main operators that are useful. You have conjunction, which is this and here, and conjunction actually works a lot like multiplication, because true and false is false, and true and true is true. Whereas with the or, it's sufficient for either one of the options to be true, or both. I have a video, in fact, to a primer on this if you need to brush up on it. I'm not going to go over it much more here, but we're going to make this a compound statement. We could say is U alpha C, or is L alpha C. And that would work. But we could also do this. We could say either the U alpha C works, or the other possibility, the L alpha. I don't know why I'm appending the parameter name there. Works. Now we could, in fact, probably remove these parentheses, but they're actually pretty good in terms of expressing your intended meaning. So we have that. Now what we can do now is when we update, we can do two things. Right now I'm not worried about resetting the game as such, but what I'm going to do is I'm going to say if oh wait, this is the wrong guy. Although we will need to be in here for a bit, or in a bit rather. Let's go back up to this guy here. We're going to say string s is equal to input input string. Now, unfortunately, I don't believe this works a character at a time. The reason it's named input string is simply because of the fact that some of these key bindings have strings associated with them. And so we will say if s length is exactly equal to 1, and then we need something else. Let's import our utility class or utility classes, and we'll say if textutils is alpha, the first character of the string, then what we can do is we'll have a private function called check. And that would very simply be something along these lines. We're going to return a Boolean here that indicates whether or not the check was successful. So we will have private Boolean check, and then we'll pass in our character here. Now by default, we fail the check. And that is because of the fact that nothing was matched. And then we say maybe something along the lines of for int I is equal to 0, I is less than letter, or what was that? Revealed length, and then I++. And somewhere here we will determine that this guy here has been successful or not. Right now it will return false, and we'll just count on that. We're not going to completely flesh it out here. So let's go back to our update function, and let's say if not check, whatchamacallit, what was that, S, the first letter in S, like that, then we haven't written this method yet, but we'll say hangman.punish. Now, punish is called whenever you lose, right? And we have to go back to the Hangman controller and write this. Update is not strictly necessary, but we can have a public void punish. And we could say something like the following. We could say if tries is greater than or equal to 0, or greater than 0 rather, then we want to reveal this. But we have to do other things as well. We need to reset this guy as well. So I'm going to move this guy down here and repopulate this with reset. And then I am simply going to go here and I'm going to say for each GameObject G in parts, I'm going to inactivate these. So that basically makes it invisible. And so what you can say is G set active false. Now, of course, we might actually want to take this out as well, because we can use this elsewhere. We'll say if tries is greater than or equal to 0, or greater than 0 rather, then actually greater than or equal to 0 is exactly what we want here. Then we'll say parts tries minus minus set active true, and that'll make it visible again. So we can briefly check this by punishing the player, and incidentally our code is well set up for that. Let's see if when it's done compiling if it'll work. We still don't know what the word is, but it does not, and the reason it doesn't, in fact, is because I need to go to the reset function here. I need to say hangman.reset, because this gets called during initialization, then it'll work. Although, I'll say here two things, really. We've got this issue to where these guys are initialized in order, so we actually do need this guy here. We need the start method to reset, and then we'll just say if parts is equal to null, which it should be initially, then we'll just return. We'll inhibit that call. And this guy will later on get reset whenever the hangman is constructed. So we have an empty hangman. Certainly right now, it looks like no deal here. So I'm going to say debug.log punishing player, just to get us an idea. And let's try this one more time. That is not being called, and I think the reason is perhaps that we have well, we should have failed that check regardless. Let's just see what we're getting here. As a result. So yeah, these guys are getting buffered here. We'll just take the first character. And as alpha is failing for some reason. So let's see. Debug.log have and then we'll add our string here and figure this out. It might be the case that we're maybe missing. We're failing a check. And that, in fact, appears to be it. Let's just go our text utils here. And it looks like the reason is that this captures the opposite of what we want to do. You see, we want C to be greater than or equal to A because that is the order in which it occurs. Now I bet you if we run it, we should be okay. So you can see I'm pressing letters and our hangman is occurring. I can press more and nothing is really happening here. Incidentally, it would be good for us to know when the hangman has died, so I'm going to use something called a property. So the deal is that the property is basically a reflection of this Hangman Controller's internal state. It's sort of a synthetic field, if you will. C# sees it as a field, but in reality it's a collection of one or two methods. So we can say public Boolean is dead, and, anatomy issues aside, we can say tries is less than 0, and we can return that. And there's no way we can modify that. So for instance, if I went here and tried to say something to the effect of, if Hangman is dead, then I'll just short circuit this to complete is equal to true. And we will want to reveal the word as well. And so that's very easy to do. We can just take the word indicator here, and we can say word indicator.text is equal to word. And so that's at least the first part of that. Otherwise, we'll just break out of this. There's no real reason for us to make this too terribly complex. Another thing we might want to do as well is convert this to uppercase. So I'm going to say to upper, and then we're just going to pull the first character out of there. And that would be simple enough. Let's go back to check real quick, because what we can do is we can say, let's go ahead and do this. If completed, next. And we don't want to do this immediately. What we'll do is if any key is pressed, so if input any key down, the next. So that is pretty much that. Say check for player failure here. And why don't we also say move to the next word as well. Now here, it might be good while we're checking this to update our score. But I'm actually going to add an update score indicator as well, which is very simply the deal here. If we go to word indicator, I actually want the set word. I want this to have length or letters is equal to this, and then for the update score indicator, we'll say score indicator.text is equal to score plus score. Let us track whether or not this has been completed as well, because we will set this guy here. So we'll say complete is equal to false, And we're basically now going to scan over this guy, and we'll calculate the score at the same time. Now we have our character here that's going to be C, and we will say if C is equal to I don't know, if C is equal to, or rather not equal to, whatchamacallit, to this guy right here, to the word, the letter in the word at index I, then one of two things will happen, or really just one thing. We will say then if the if revealed I, rather I'm gonna have a complete counter here instead of a Boolean. That seems to be the best way to do it. But if revealed I is not equal to 0, then complete plus plus. In fact, we didn't put this guy here like this because it won't matter. But if it so happens to be the case that we do happen to have a blank spot, then we want to increment the score, right? So let us go ahead now and we will say revealed I is not equal to 0. We know from this that in fact, we'll just make this an AND statement. If these two are equal and revealed I is not equal to 0, then we'll set this as such. This is all it boils down to, really. So in that case, we have the word, or the revealed, rather, is equal to C, and we also will say score plus plus. Other things to do as well. Let me just get this score, by the way, because it is set, is to come back and check and see, first of all, if score is not equal to 0. And we do actually want to we'll want to say here, maybe even break this down a little bit, because we do want to definitely make sure we have the score, but we also want to set the return value to true here as well, so that if we hit another character more than once that's already in the word, it won't take away the score. There we go. So now we're doing score manipulation, and we're going to say this dot score is plus equal to score, and then it might be useful to have a bonus for completing the word, because longer words are harder. And so what I'm going to do here is I am going to say that if complete is equal to revealed dot length, then this complete is equal to true, and incidentally that this score is plus equal to revealed dot length. And then finally, update score indicator. Now, as it stands, this guy is actually case sensitive, and that's no good. I'll show you how to fix that here in a bit, but now we have everything that we need. Elf is not one of them. Oh, you know what else we need to do? We need to update the word indicator as well. So update score indicator and update word indicator both have to be done. And if we try this again, then nothing is showing up for some strange reason. And Unity is insulting me for another strange reason. Oh, but yeah. Let's real quickly go ahead and debug this real quick. Revealed I has to be equal to 0 here, that's why. So yes, errors like that do pop up all the time if you're not careful. It's because I changed the way things were working. So yeah, actually it isn't case sensitive, but you can see we entered F. We got 1 point for that. We should have 2 O's. About an L. Oh yeah, so the reason is that the word itself is case sensitive as well. So we're going to say word then is equal to word dot to upper, and that way it doesn't matter whether the player hits shift or not. So FOL, we got 8 points for that. Very nice. The the deal now is that we want a dictionary. Actually, we do need to test one thing out. FOL, and then see if any key is pressed. For some reason, FOL. There we go. That bug there is rather unfortunate. We need to clear the input string if we do that. And my guess is that because we haven't been checking the input string, what has happened is that we have completely lost this. So we'll just say input dot string is equal string temp is equal to input string. That should fix that particular issue. Finally, I do want you to sort of take note here. There we go. The player should not be punished for some reason. I'm going to look into that and figure out what's causing it. I think it's because of the updates between frames, and we could actually get around this by saying if key down. I think that is the solution here. You might ask, why are we not using a text buffer here? And we'll say if what is it, input key, any key down. I'm going to return here as well. If If not any key down return, we don't need to do anything there. That is simply game logic. But you might say, why are we taking this convoluted approach instead of using a UI object? And you could, in all honesty. But the UI object works pretty well here. Now I'm going to add me another thing here. I'm going to add a new utility class. I'm going to call it a dictionary. And the dictionary is basically where we will look these guys up. So the idea here is that we have this dude who, oh, there we go. Basically, we're going to have a function in here called public string next, and then we're going to pass in an integer named limit. And that limit is going to be the maximum number of characters in that word. Now, here, you might have noticed I have this resources folder. We have not really talked about that, but we need to now. And I need to return a value here. We'll just return the empty string for now. The resources folder gets baked into your application whenever you compile it. And then using the resource manager, you can actually go through and load these guys as part of the application. So I have this word list. We do need to skip the first couple of lines in it because or actually we don't have to, but this is out of Moby's lexicon. It is empirically derived, and this is only the 1,000 most popular or most frequent words in the English language. At the time this was compiled, at least. This was compiled in 1992. The author has been very gracious and has released this under public domain, and it actually has a collection of 610,000 words. But again, because it's empirically derived, you have to do some work with it. And that work is basically filtering out profanity, unless you want profanity in there, because it's because of the way this was sourced, so the words themselves are not, they're not checked for connotation or anything like that. So you do have to be careful about that. If you want your game to be kid friendly, then it's worth your while to do that. Also, the larger lists are just simply too large to work with. So we can basically do a couple of things here, but we have to, we have to do some work here. So I'm going to use system.io here, and I'm going to create a file or a function called load. So this is going to be public static load, public static dictionary load. And the function of this guy is to load the dictionary on demand. This is actually going to be a private constructor, which means only this class can construct a dictionary. Very useful for us. And we'll just say character words. We will also use system.collections.generic. And we will get this guy loaded. So the first thing for us to do is to create a place for our words to go. And what we'll do is we'll create a hash set. Now a set contains, it, it can really, it doesn't contain duplicates and it doesn't put them in any order per se. We're going to have a set of strings that represents our words. And we will call this the word list, and we have to construct it. So I'm going to do that. Conveniently, Mono does the constructor for you. Now, we haven't really seen the constructor. I think this does take a little bit of explanation. Constructors are kind of like the start method in that they create objects, but whereas the start method may get called multiple times, the constructor only gets called once, and that's during the object's initialization. And the start method is specific to Unity. The constructor is a built-in part of C#. So we'll look at that, but what we want to do now is we want to create a text reader, and we'll call this, we can't call it in, I'm going to call it SRC. But to do that we need our assets. So we need a Unity engine. We'll just import that entire namespace and we'll say text asset is equal to resources dot load, and we won't put the extension on this. We'll just put words because that's the name of our file in the resources folder. And then we're going to cast this to a text asset because we know that this guy right here has to be a text asset because of its extension. Now we can say new string reader, and we can pass in the asset text. So we'll just say asset.text, and then finally we'll say the following: while src.peak is not equal to -1, and -1 is returned whenever, in this case, whenever the end of the stream is reached. It's whenever no text is available, basically. Then we'll say string word is equal to src.readline. So this guy reads this a line at a time. I'm going to create a private static boolean is word okay. And then we will say something along the following: word is okay if and only if for, first of all, for each character, we can have a count of vowels here because that'll become good later. And we'll have a vowel limit too. Actually, no, we don't need the vowel limit, but we do need the we do need this. We'll say for each character in the string, if not text utils dot is alpha word, return false, otherwise return true. So we're assuming here that the word is okay, and then we're explicitly looking for when the word isn't. Also, there's another deal here too. We want to say if the word length is less than 1, it's not okay either. Having a blank word is not usually a good idea. So, Now all I have to do is say if the if is word okay word word list dot add, and we'll add the word in. Now finally, we need to convert this guy to an array because the hash set itself cannot be indexed. That's just the way that sets work in C#. So what we'll do is we'll say char array words is equal to new words, and then we will pass in the count on that word list. And that there is just a property. And that's actually a new string, not a new word. These are a new character array. This is an array of strings. And finally, we'll have a static variable here that we'll call private static s instance. That's of type dictionary. Now there's actually an important reason why we're naming it with that prefix. That prefix is something called a Hungarian notation. You'd see this a lot in C, or C++ rather, because fields and methods share names. In C# they don't. However, they do, the properties share names with them. We want to create a static property. So we're going to say public static dictionary instance is equal to return s instance is equal to null. If it is equal to null, then return load. Otherwise, return s instance. And that pretty much does it for the getter, or for the accessor. The two are more or less synonymous in terms of object-oriented programming. This guy's just going to be called instance. Now all we have to do is say s instance is equal to new dictionary words and return s instance. We don't want to load this every time the dictionary is requested, so we'll say if s instance is not equal to null, return s instance. We're almost done with this. We just need to get one more bit going. We're going to copy the string array in, so we'll call this words, and we will say this words is equal to words. Now arrays, by the way, are objects, and what you're doing here is you're copying the reference. You're not copying the word array, so this is not losing anything. Another thing we can do as well is we can say maybe asset. There's no unload for this, but we might as well check. Unload asset, and we will pass in the asset. That way we do not keep this guy hanging around in memory. Finally, we need to do something kind of like the following. Basically, the way we are going to pick the random index is we're going to go from 0 to the word length. And so we'll call this index is equal to Unity engine. In fact, we could do random, but random is ambiguous. We could actually get rid of that possibly by taking out the system namespace. That would actually get rid of the ambiguity, so we can now say random.value times the word list length. But we're going to have precision loss here. So we have to do that, and we also, because we get between 0 and 1 inclusive, we actually have to set the word length. We have to subtract 1 from it. And so we'll return words.index. In that case, I'm not going to bother with the limit right now. We're running short on time as it is. But what I will do is I will update the game controller to use this. Now all I have to say is set word dictionary dot instance next, and we'll pass in 0 for now. Let's see if we have any issues. In dictionary we do have a minor one, it looks like. We have in 31, wherever that may be. Looks like it is up here somewhere. And what is the issue here? Oh, we need for each. Yeah, this isn't Java. The best overloaded match is alpha. Is alpha C. There we go. We should get a random word. I have no idea what this word is. Let's see our console. Set word to system string word. Okay, something here is happening. Oh, we forgot to do one minor thing here. We can create the array, but we didn't populate it. So let's say word list dot copy to then our words. And that should pretty much do it for us. We have a random, looks like a 7-letter word. E is the most frequent letter in the English language, by the way, in case you were wondering. There's no E, or is there? We broke this somehow, it would seem. What has happened here? Are we inhibiting this in any way? We'll just take that out for now and fix any bug that arises later. I think now this should work. So E's not a word, I'm is not in it. We just did A. O is in it. So we know it's a word with an O, no A, U, or I. Actually, we didn't try U. Off. Off is the word. There is also another deal here. We have a 7-letter word. One thing we do need to do here as well. I know I keep on putting off the end, but in our reset we do need to set completed to false. Otherwise, this hangman will never get changed. So we have A, E, try T, R. You know, actually that compounds me red. There we go. This, whenever this guy is... It's not whenever this guy is set, but whenever the word is set. That would do it there. One more go. So, yeah, let's just do what we can to complete the game. We have to reset the Hangman here as well. We'll just move this in. So now we've got these bits and pieces that, sometimes these bugs happen. And it's just the way things are. But, yeah, one more go. Can we fix this guy? That's dark. There we go. So now we at least have a game that has random words being pulled from a file. Briefly, I will go over quickly what we did with the I/O one more time, because I do know that maybe I didn't go over it that well. We basically created a list of words, or a place to store our words, rather. We loaded the asset, in this case, the word list, and then we read all of the lines until the end of file was reached. We unloaded the asset that we read the dictionary from. And then finally, we came down here and we set up the dictionary. So if you have questions about this, let me know. Until then, this is Lord Root, and I will see you later.